The world is full of fear, mystery, and sometimes horror. Among them are supernovae, the most powerful and dynamic events known to science. These massive stellar explosions produce more energy than a billion suns in the blink of an eye and emit massive amounts of radiation across the entire energy spectrum, from radio waves to gamma rays. These explosions are so powerful that theoretically, the entire world will feel the effects of the explosions one day. The discovery by the James Webb Space Telescope, JWST, humanity's newest instrument for observing the universe, has excited the scientific community. Betelgeuse, a famous and popular star in our night sky, is showing signs of an impending supernova. Will we witness one of the most incredible events of our lifetime? Before we unravel the mystery surrounding Betelgeuse, it is important to understand the significance of another important event in planetary history, the supernova explosion SN 1987A. This event is a key benchmark for understanding the life cycles of giant stars like Betelgeuse and the tragic yet beautiful fates they face. Discovered in 1987, the cosmic standard supernova SN 1987A is one of the brightest and closest stellar explosions ever observed. Century. It is located 168,000 light-years away in the Large Magellanic Cloud, a galaxy close to our own Milky Way galaxy. During its explosion, SN 1987A released enough energy to be visible to the naked eye from Earth. Since its initial discovery, astronomers have been tracking the expanding supernova remnant to understand the processes that affect the evolution and death of stars. SN 1987A is so important because it has been observed extensively by a variety of space probes, including NASA's Hubble, Spitzer, and Chandra telescopes. Now, the James Webb Space Telescope has taken this research to a new level. Using its unique ability to see in the infrared, JWST captured the most detailed images yet of the structure of SN 1987A, including the equatorial and outer rings, the crescent-shaped inner ejecta, and the strangely shaped main vent inside. One of the most intriguing features of SN 1987A is its inner equatorial ring, formed by debris ejected from the star tens of thousands of years before its supernova explosion. When the supernova shock wave hits the structure, it creates the bright hotspots seen in the JWST images. The telescope also detected structures similar to quaternary structures in the outer layers of the atmosphere, which are likely remnants of the ancient explosion. The explosion, which is likely the end of one of the most massive and brightest stars in the universe, may serve as a planetary laboratory. By studying SN 1987A, scientists have been able to reconstruct the final moments of the star's life and draw conclusions about the fate of future supernovae, including Betelgeuse. Located in the constellation of Orion, Betelgeuse is one of the brightest stars in the night sky. It is also one of the largest, at 900 times the diameter of our Sun. If it were at the center of the solar system, its outer surface would be beyond the orbit of Jupiter. Betelgeuse is a massive star that has reached the end of its life as a red giant. Astronomers have long known that Betelgeuse explodes in supernova explosions. However, in 2019 and 2020, Betelgeuse made headlines with its unexpected departure. Stars like Betelgeuse can vary in brightness, but astronomers are interested in how quickly and how much they dim. Observed by several instruments, including the James Webb Space Telescope, this faint phenomenon has raised questions about its cause. Could this be a sign that Betelgeuse is headed for a supernova? Several theories have been proposed to explain Betelgeuse's sudden dimming. One theory is that it is caused by a huge cloud of dust passing in front of the star. As a massive star like Betelgeuse ages, its outer layers deplete, producing dust and gas. This ejected material dims the star's light, making it appear dim from our position on Earth. Another possibility is that Betelgeuse is associated with shooting stars. Massive stars undergo multiple expansions and contractions. These bulges can make the star bigger or smaller, and their brightness changes as the outer layers move closer or further apart. But the most intriguing theory is that the blackout could be the beginning of a supernova. Betelgeuse, which has a mass of 20 times that of our Sun, is nearing the end of its life. When its fuel runs out, its core collapses under its own power, causing a massive explosion. In the past, stars have been found to undergo unusual compressions before they explode in a supernova. Could Betelgeuse be close to such an event? The consequences of a Betelgeuse supernova explosion would be astonishing. If Betelgeuse were to explode, the supernova would be one of the largest astronomical events observed in human history. The explosion would make the moon so bright that it would be visible from Earth during the day. For weeks or months, Betelgeuse would shine above all the stars in the night sky, becoming a beacon of light in the sky. But this explosion goes beyond the visual aspect. Supernovas release a great deal of energy in the form of radiation and high-energy particles. Gamma rays produced by the Betelgeuse supernova are visible around the world. However, given the distance between Betelgeuse and Earth, about 642 light-years, the radiation poses no threat to Earth. The shock wave from the explosion also travels through space, compressing and compacting the interstellar medium, creating a fiery bubble of ionized gas that can last for thousands of years. The area surrounding the ejecta is rich in elements such as carbon, nitrogen, oxygen, and metals, which are essential for the formation of new stars, planets, and potentially life. Astronomers have the ability to study nearby supernovas in real time. The data collected will help us better understand the life cycles of massive stars and the mechanisms of star formation. Watching Betelgeuse die could help us understand the fate of other massive stars in the universe, as well as the formation of heavy matter for planets, moons, and life. Betelgeuse's fate is one of the most intriguing and mysterious in the modern universe. Predicting the exact timing of this explosion is not easy. Massive stars like Betelgeuse become unstable as they age. Astronomers know how stars grow and die, but determining the exact timing of a supernova is difficult. One reason for this remarkable feat is the complex physics of Betelgeuse's core. Stars gain mass by burning their cores and going through various stages of nuclear fusion. When a star starts fusing iron in its core, it collapses and becomes a supernova. However, it is very difficult to determine exactly when Betelgeuse will start melting iron and exploding. A faint event in late 2019 and early 2020 led to widespread speculation that a supernova was imminent. The star's brightness decreased by more than 60% in just a few months, leading many to believe that a collapse was imminent. This phenomenon, called the Great Anomaly, has sparked numerous observations and theories. Some scientists believe that Betelgeuse's appearance is a sign that it is entering its final stages, while others believe it is due to surface activity or a cloud of dust obscuring the star's light. In the process of understanding Earth as natural light, this event revealed an unexpected nature of the star's behavior. This uncertainty is a reminder that large stars like Betelgeuse can undergo dramatic changes in a short period of time. Astronomers are using advanced space instruments to better understand Betelgeuse's characteristics. One of the most important instruments for this task is the James Webb Space Telescope, JWST. Equipped with an advanced infrared sensor, JWST can observe stars and other celestial bodies in unprecedented detail. By studying Betelgeuse's light, heat, and radiation, scientists hope to learn more about Betelgeuse's internal processes and whether a supernova could be closer than we thought. JWST's sensitivity to infrared wavelengths allows it to detect subtle changes in the star's environment, giving astronomers a clearer picture of changes that could indicate an impending explosion. In addition to monitoring Betelgeuse's brightness and temperature, the telescope can also test the star's brightness. This will allow astronomers to determine the chemical composition and emission rates of Betelgeuse's atmosphere. This information will help scientists track the star's evolution and estimate how long it takes for its core to collapse. If Betelgeuse is approaching iron fusion, JWST's instruments could detect the transition, providing the first real evidence that a supernova is imminent. If Betelgeuse is close to supernova status, astronomers hope to see telltale signs before it explodes. One key sign is a sharp increase in the star's neutrino production. Neutrinos are massless subatomic particles that are produced in large quantities during stellar nuclear reactions. When a star like Betelgeuse begins to collapse, its parent star emits a burst of neutrinos. The observation of this particle influx strongly suggests that this supernova occurred. Neutrinos are difficult to detect because of their weak interaction with matter, but there are still many underground neutrino detectors around the world, including Super Cameo Candy in Japan and Ice Cube in Antarctica, that are searching for these complex particles. If Betelgeuse starts emitting neutrinos at a faster rate, these observers will be the first to know. As a result, the future of Betelgeuse is still uncertain, but its fate is set. Whether the star goes supernova tomorrow or 100,000 years from now, one thing is certain: explosions are major cosmic events.